All right, now we're good. So we'll go attack this one. I'll take this one out, like showing every step. So we'll just begin. You first need to. The thing with integration is there's so many different integration techniques, so there have to be triggers. We were doing integration by parts in Calc 1 today, and I told them the trigger usually is when you see incompatible functions, right? There's usually something that triggers the process. Otherwise, it's just kind of stabbing in the dark and trying to find what works, and that could take a while. So when I see a root and I see squared things in there, this does trigger the substitution, the trigonometric substitution. Under this root, again, my goal is to create that perfect square, and I've got those Pythagorean trigonometric identities that we were using. Identify the correct one. This is in the form sort of a squared plus u squared. Which one is that? It's kind of 1 plus tangent squared that I would like to create. So I will take that x and I will create something. And again, I always tell you that's kind of the beauty of math is you just get to create what you want as long as you don't do two things, which is weird, right? Don't divide by 0 and don't root negatives. It's kind of all fair game here. So I'll let x equal something that will create that tangent squared in there. I obviously need a tan theta, so I can get that. But that would be 4 plus tangent squared. I need it to be, what else do I need in there? 2. Yeah, I need to create something so I can factor that 4 out. And I think yesterday you guys, I think I only saw like one incorrect choice, and it was a bad choice because you picked the wrong identity, but you knew what to do. So we'll do that. Then I would create everything in the integrand right now. This is just after teaching this for several years that, like I said yesterday, get all your ducks in a row. You know you're going to need to get rid of x, and we're going to go all theta in this problem. When I'm done dealing with theta, I'll kick them out and throw x back in. So my x squared would be 4 tangent squared theta. I'll take care of that. Also in my help over box, I have to get the derivative of x with respect to theta. Dx d theta would be 2 times what? Secant squared. This is all stuff to help me alter the integrand, and I'll do that in a minute. But yesterday I told you just to stop. This is to help you at the beginning, and then when we go back and get rid of theta, there's 2 things that help us out. The reference triangle is helpful because although I know tangent is x over 2, I might need cosine, I might need sine, I might need secant. So go create your triangle right here. Tangent of theta would have to equal x halves. So what that means is you can get any trig ratio you need at the end, right, back to x. If you need cosine theta, you can get it. Tangent is opposite over adjacent. And then create your hypotenuse. What's your hypotenuse going to be? Yeah, what did I tell you yesterday about that? Was anyone gone yesterday? Because this is going to be like, you're going to get a little goofed out here. But let's help Dylan out. What did I say about if you get to this point and you created that triangle, what did I say always happens? Exactly, Annie. Whatever your missing piece is on your triangle, this hypotenuse, it's always your issue in the original integrand. So that's a nice check. I found this, it matched my issue, it was good to go. The next thing I told you to do is also get theta, because any theta in my answer, I've got to go back to x. So in this scenario, what would theta be? Arctan. All right, I think we've got the whole basic, how do I get started down? So now what your issue is going to be today, and I like to put that in a box and just say, all right, there's my help getting started and help finishing. My problem now is going to be in the middle. It's going to, what did I do? Arctan x. Oh, sorry, arctan x halves. Thank you, Annie. I said it and wrote theta. Let's go over here now, and that's where if you have a big sheet of paper, it's nice to work on down. I'll move it on over. I'll take this first helping box and replace my entire integrand. I'll integrate 1 over x squared, or tangent squared. And I'm going to have the square root of 4 plus x squared. And I'll show everything on this first one, just because for Dylan's sake he was gone yesterday. So I will replace my x squared next, 4 tangent squared theta. We have time to help you, Dylan. All right, you will be. We did all the build-up yesterday. but you'll figure it out. Somebody in your group will help you tomorrow. I'm not going to help you. All right. dx is 2 secant squared theta. It always looks way worse. Like it should look like, wait, we talked about like trig vomit up there, but it'll get better. This was the whole reason we created it, remember? So I think I'll do a little canceling here and pull a half out front just to clean that up. I'm going to leave the 1 tangent squared theta. And then under there, can I do that in one step? You all right with that? I did this so I could create 4 times 1 plus, I'll have to do it. 4 times, my attention to detail today is not going to be cut short on the hardest thing we do. I will. Are we all right with what I just did? That was the whole reason, again, for this guy's choice, is so that right here, I can pull the 2 out. I'll do that right now, make a 1/4. And then leaving under that root a nice perfect square, because what is 1 plus tangent squared? Secant squared. Awesome, aren't they great? Like, can you imagine have done this in high school? This is crazy, they're so good. I know, this is like, you guys just make my heart happy. All right, so where was I? Secant squared, right here. And under the root, that's going to pop a secant out. Watch my arithmetic. Again, talking and doing it. You'll find when you're teaching it, this is, I get lost in this too. So over here, secant squared theta. And I did my own pet peeve, forgot my theta. All right, so now let's do a little reducing. Let's double check LaRue though. Am I good? Do you see anything there? I'm good so far? All right. So 1/4 out front, I'll take out a secant. So far, this setup, nothing should have tripped you up here. So had this been an exam, you're full 8 out of 12 points going here. You should be golden. Here's where now you're going to get stuck, because I gave you a full safe way to start, and we've got a really good way to finish. It's once your integrand gets cleaned up, then you have to think outside the box, and that gets tricky. But I have a secant on the top over tangent squared. And this, once you get your integrand cleaned up, that's now our biggest issue. Is it U sub? Is it more replacing trig functions? Is there something by partsy in there that I need to do? It's all, I don't know, you have to try stuff. Here's my one. Maybe you've been with me for so long, you probably know. When I see, and I don't know that it'll work, but when I see secants and tangents, what do I usually do? I go sines and cosines. Now, if that's not helpful to me, then maybe I would try replacing tangent squared with its equivalent. Or I try mess, but you have to, that's where it gets fuzzy, because the same thing doesn't work every time. And here, when you stumble upon what does, it actually is like scratching an itch, which is another reason I love math. Like when you work it and you're like, I got it. All right, let's go replay. Yeah, massage. Yes. All right. It's just when you massage it and that kink is still there. That's very frustrating. I had a proof once that was assigned to me, and I had a week to do it. And I thought, oh, a week to do one. That ought to be easy. And it, like, literally, I wanted to kill somebody. Like, it drove me insane. Sine squared over cosine squared on the bottom. So let's multiply by a reciprocal. Let's go cosine squared over sine squared. Again, if this doesn't work, I'm going to cross off everything in blue. And I'll have to try something else. That's why we don't do our math in pen. So, where am I here? I'll cross off a cosine. I'm going to do it off on the side, just in case I'm walking on a path that I'm going to have to abort here. Cosine over sine squared. All right, so that would have been my first try, is to go to sines and cosines from my tangent, cotangent, secants. Looking at that integrand, it gives me kind of like a hug, because this is a good integrand. This is what? This is U sub. So that's a good option. Now, I want to talk, that works a lot when you get out of these, but had it not worked, I would have had to try something else. I maybe would have replaced tangent squared with something. Maybe that would have worked. You try. All right, so this is working for me. Who is my U? Sine. Yeah, so I'll just do it from over here and go straight to U. So I've got U is sine theta. du is cosine theta, and I know most of you don't write this anymore, and I'm fine with that. But just so you know, you're looking at 1 over u squared du. Correct? So 1 over u squared du. If you tell me that's ln u squared, I would be mad. You shouldn't do that anymore.
Yeah, you fraction.
What?
You got the fraction correction.
There isn't one.
Shut up, Rowan.
No. But I was talking about like in the ln.
Oh, gotcha. All right. So
It wasn't that funny.
you're messing with my head. So I have u to the negative second, right? I'll add 1, divide by that. Let's just go negative 1 over u. I'm good. Plus Carl. So I really, that's kind of irritating me too. There is my answer. True or false? I am done.
No.
I actually have a double-decker back substitution to do. See, do you see why they can't put these on the AP test? You would never finish. And were this an FRQ, it's a huge chunk of points devoted to one skill, so they can't do it. All right, so let's go back. Who did I say U was? U was sine. All right, so I'm back to theta. Theta's great. So then I have to take and go back. Again, this problem wasn't about U, and it wasn't about theta, and it wasn't about me. Right, it was about x. So go back up. Where did I tell you yesterday to go to get back to x? Where do we go?
Triangle.
Back to the reference triangle. That's why I suggest you make it. So back up to my helping box. This isn't helpful to me right here in this problem, but this reference triangle is. Sine would be opposite over hypotenuse, so it'd be x over root 4 plus x squared. So my final answer, Rowan, it would have been nice if you had your thing on. Root 4.
Bang on.
He's usually. You guys are in a mood today. I like it though. At least you're not sleeping. Yeah. They've been sleepy because it's getting difficult. So I feel like because I have so many of you watching me that's correct, but that makes me nervous because I was doing lots of stuff. It's good. It does. I'm gonna have you wolfram it though, just because I can't
Working
leave.
that thing, Rowan?
You working on Yep.
I was just gonna say, when you were before doing the U sub, when you had the cosine over sine squared, one thing you can do is turn that into cotangent and cosecant, and
You could go that route.
yeah, you can.
Yeah.
You can if you recognize that. You can
And then
just
go back
do-
to your triangle
yeah,
there.
do
We
your
did it
negative.
right.
Yep. Did they leave
Wait.
it like that? Did they rationalize the denominator or they
You missed the over x.
where?
And
X
sine
on
sine
X
theta is
over
the
Oh, the x over. Sorry, yeah, I said it there.
yeah.
Did they rationalize the denominator?
Yeah.
Yeah,
Wait,
overrated.
that
All right.
was so wrong.
Rude. Look at mine.
We're gonna go.
Wait, we did it wrong?
No, we
You're
didn't.
on
do it
7.
wrong.
You just gotta
Yeah.
No, we didn't.
Go
No,
to
no,
triangle.
the right should be on
Go
top.
to
The x should be
Oh, the root's on the top.
Yes, the x is on
Because
top.
it was 1 over. Sorry.
Yeah.
Before X.
Thank you. Thank you. It was on the bottom. I didn't flip it. I get you. All right. Next one up. Let's go do in reverse. What number was that? 7. We're going to go back and do 6.
Yes.
All right. So this one's got an entirely, that one had a little bit of an issue, but it's pretty straightforward. Let's see what this one has going for it. It's going to get large, I can tell, because of the x cubed. But let's begin here. First choice. Who's x? And this one should be, this one, 3 sine. Yeah, we're good at that now. 3 sine, except for Dylan. That Dylan. The accent Dylan. So that's our choice for x. And again, let's get all our ducks in a row. Might as well get x cubed laid out. This is not point worthy, but it's good practice. All right. My dx I would do next. Dx d theta would be 3 cosine theta. That's going to help me with altering my integrand. That's an easy start. My next thing is get my triangle on there using this. So I'll have my sine theta being x thirds, and I'm going quicker here because we were good at this. Jenna, thank you for getting him on the road because I'm not slowing up for Dylan. Train's moving, Dill. Poor guy. All right. Was not a good day to be absent. you're listening to this, we're waiting for Dylan.
Okay, I got it.
Alright, hey. Alright, so next up, right here I'd also get my theta as arc sine x thirds in case I need that later. And now I'm ready to roll. Maybe get this out of the way and remove it from your working space, which needs to be quite large, but I'll move it over there.
Square root of 9 minus x squared. Triangle.
Bottom
Oh,
right.
yep, there it is. Thank you. Wrap up your triangle. Notice again, what the missing part of your triangle is the issue in your integrand. That's a really good catcher. It's stopping you from doing it incorrectly before you even start. All right, let's begin here. We will integrate x cubed, 27. Might as well pull it out front. Sine cubed theta. All right, square root 9 minus 9 sine squared. And some of you can skip that step if you would like to. I can't, I'm the teacher. Dx 3, put the 3 out front here, I think. Cosine theta. Oh man. If only the pre-calc teachers could come in today and see why we do so much trig and pre-calc, right? Holy smokes. All right, let's clean this up. 81. Keep the sine cubed. What's this going to become under here? Yeah, it's going to be 9 cosine squared. It's going to be 3 cosine. Let's put the 3 out front just to keep all that constant mess out. Cosine squared theta d theta. All right. This is now this part should be smooth. We had such a slow build to it between yesterday and today. You should be going, again, except for Dylan, should be going, yep, get it, got it, good. Now what's going to trip us up isn't the end. I mean, it tripped me up because I was being sloppy and talking. This is where you're going to get stuck. When you have a clean integrand and you're trying to anti-differentiate it. It's a matter of trial and error for some of it. But did I do something wrong? It is u sub, I'll guarantee you that. However, you're going to have to be clever. So I will start trying u sub, and then because I want you to see the process evolve. I don't just want to tell you who u is. I'm just going to stab in the dark like you normally would. I'll say, well, I'm going to let u be sine. Then I'd have u cubed. That'd be nice, right? I like u cubed. U to the 4th over 4, it's great. But du is cosine d theta, not cosine squared, and there is, yes.
You just change cosine squared to 1 minus sine squared.
Well, okay, let's try. That was going to be, so I was going to say that next, because that's kind of, you do need to do exactly that. You need to flirt with it. So I tried sine. Its derivative was cosine, not cosine squared, so that's a bad choice. Then I'm going to, off to the side, I think I'll keep out of the way. He's saying, why not take cosine squared and do 1 minus sine squared theta? Well, still, kind of close. Like if u was sine, you have u cubed, 1 minus u cubed, but du is cosine d theta. If I distribute it in, I've got powers of sine that I'm not quite sure how I integrate, but you're on the right track with the u sub. And you're on the right track with breaking things up also. So who didn't I try letting
Sine
u
squared.
be? Okay, okay. You're seeing it, so shush. All right, I have shoot. Cosine. Now, again, if I let u be cosine, let's write it on here. U is equal to cosine. Really, I've almost exhausted all of my possibilities anyway, right? So if u is cosine, this would be u squared, but its derivative is negative sine. All right. However, I can introduce a sign here. How could I do that? I could call sine cubed. What could I call it? I'm on the right track. Right, this is where we're stuck, and we should be, but you gotta kind of tweak it again. Here's my issue, I want you to kind of pick inside my brain. I first let it be sine, it wasn't happening. Then I tried your suggestion, it still wasn't really happening for me. The minute we said u being cosine, I actually saw it. I'm like, okay, I've got u squared, that's great. I can get du over here. I can get a sine. If I call this sine times what? Sine squared. Just watch it. Sine, I think Rowan, you saw it, so I shushed you. But I almost have it. Because this would be u squared, this would be negative du, and how can I write sine squared? That was what you were on to. 1 minus cosine squared, so you have 1 minus u squared, and the light bulb went on. And you might say, I would never think to do that. You wouldn't until you tried everything else, and that's where you're sitting taking a test, and you're like, oh, fine. Or you're like, shoot, I failed that one, because you can't get past this hump. And I can't teach it any better than how I'm teaching it, which is just to say you've got to exhaust all possibilities, but you're all on the right track. You knew it was u sub. You kind of knew this one. Hanson brother knew he kind of needed to get out of one of the use of Pythagorean 1 minus something. Let's go do that. So I have the 243. I'm going to write this as sine theta, sine squared theta, cosine squared theta, d theta. And I'll go with Rowan's U choice. Here's why. I'm going to steal Tyler too. You guys are kind of a group effort here. I like it. He said change this one to 1 minus sine squared. He's really close. I'm going to change this one to what? 1 minus cosine squared theta. Yeah. I might not take this one all the way to the end because once I get over this hump, it's going to be smooth sailing again. But I'll take it on out a little ways. Here's my 243 that I don't want to forget about. Now I've got a viable u. Who u? Cosine. Watch what happens then. I have 1 minus u squared times u squared, right? And what's du? Negative sine theta d theta. So negative 243. Could you get past that now? Now, just talk it out with me. Now what are you going to do? Distribute. Then what rule? Power rule, right? Then you're going to have something in terms of u. Now, I know you guys are smart. You're dying to finish it. I can see you. Just stop. This is where it's easy. But once you've got it all in terms of u and you've done your power rule, what are you going to replace u with? Cosine. Once you're all done with that, what are you going to replace cosine with? The triangle stuff. And it'll be like mechanics and like a bunch of arithmetic algebra, but that won't be your issue. Again, once you're good at them, the beginning, smooth, the end, always smooth, it's in the middle, it gets a little funky. All right? I'm going to bail on that one. Let's go dot, dot, dot. All right, one more to do together, and then we'll take a break since you're listening so well. And this is the one that you might want to go to the big slice. One of the groups tomorrow. Maybe we should give it to the group who's gone.
Yeah.
Yes. The
They're
group.
listening. You need to stop recording. Just turn it off.
Well, no, because then they won't understand. They'll make sure they listen. Because the other ones, they might be a little big. Oh, could you have figured those two out without listening? I don't know. The first one.
No, absolutely not.
Yeah, all right. Even the guy who's been through top 5. All right. Did you do them harder than this or about the same as this?
About the same as this and a little harder, and they actually had these on the midterm and the final where you had an hour and you had to do like 3 of them.
Isn't that crazy? So you guys whining? I told you, I'm gonna expose you to it.
That's why I'm not gonna laugh.
Yeah, that's right. You want that?
That's
All
why
right.
all of you guys don't have to take this. You can just go on to the next stuff.
Yes. All right.
Honestly.
So the next, it is. This is the hardest, I think, one of them. I like the series messes with my notes, but
Zero on that.
there you go. Series, polar, whatever. All right. So this one. Here's again. You gotta kind of go with the brain flow of it. Like after you've done them enough, which you won't do enough of them because we don't have enough time. But I look at that and I say, I've got a root in my enneagram, right? That triggers this process, trig sub. The problem is in that enneagram, I'm not seeing that Pythagorean triple identity stuff. What that means is I still need to, like I said, like massage it and get it to work for me. How do you take from algebra 2 a quadratic? Perhaps it's x squared plus 6x minus 11 and create something squared minus 11. There it is. Oh, yes, something we haven't done since we were in 9th grade. We're going to do it. This is going to require me to create something squared. So let's talk about if we don't remember how to complete the square, never understood it. If you haven't used it for a long time, it requires quadratic form. So we'll put this in the correct order. How long has it been since I complete the square?
About
Algebra 2.
4 months,
Good,
yeah.
that's good to review it. Anyone, if it were juniors, I'd say anyone gonna retake their ACT, but you guys are done, but. All right, so if you remember, the best way to approach completing the square, and I've never taught Algebra 2, truth be told, so I'm not quite sure how they tell you to attack it, but I always say, let's get the negative out, because I hate them. So I factor a negative out. All I'm doing right now is playing. I am not even starting to integrate. I'm not starting trig substitution. I'm playing with my radicand. All right. What'd you guys do today in Calc? We played with our radicands. All right.
Sounds right.
Doesn't sound right, but it's exactly what I'm doing. I'm playing with my radicand. Because, all right. So if you remember, in completing the square, you got to remember parts of it, right? What do you do? Huh? Add 9. How do you get the 9? I mean, this is old school, but you guys are past old school. Yeah, you take half the middle term, square it, and add it. So you are correct, Mr. Bradley. I am going to, in here, complete this by squaring. It's got to be some quantity squared. So you take half the middle term and square it. However, you've got to be very careful with this common mistake amongst Algebra 2 peeps. You do. You need to balance that out because you can't just say, oh, I'm going to add 9 to it and say I did the same thing. But actually, you didn't add 9. You subtracted 9. Now watch, just for the heck of it, verify that this is right because I don't want to go through like 15 minutes of a problem and have this have been my issue. So I know it's right because we were methodical, but I would just, if it were me and I'm the one in the group that has one like this tomorrow before I moved on, I would just make a dump here. Negative x squared plus 6x minus, it's just getting worse. So, okay, negative x squared plus 6x minus 9, right? And then I have the plus 9, which wipes it out. I walk myself right back to the original. So then I'm safe here. Then the whole reason I did it, no yawning kids, is I wanted to create a square. A perfect square in there. Square upon theirs. There it is. Now, trust me, if you were to FOIL this out, negate it, and add 4, you'd be right back to the start. I technically just spent 3 minutes doing absolutely nothing except molding it, massaging it. All right, so this is almost in a form that's workable. This is why we're on a big slice. We'll for sure make John and whoever else is gone tomorrow do the one like this. Here's what I will do. I have this now sitting here. Woo! There. Are you ready? There. That is now something squared minus something squared. And it's a constant squared, aka a squared, minus a function squared, aka u squared. Which trig identity is it? It's 1 minus sine squared that I want to create. In order to do that, I need this right here to become 4 sine squared, correct? Because I want to factor the 4 out, right? So, what does x minus 3 have to equal? Not 4. 2, there, you're close. There. And then if you're not sure, run a check. Plug it in. You'd have 4 sine squared, you'd be good to go. Again, this is where you stop, though. I'm going to go from x to thetas. We should get all our ducks in a row here. Yes, I'll replace this with 2 sine theta. I'll square it. I'll get 4. But I've got dx to deal with as well. That's one of the most common mistakes by kids who don't understand the process is leaving a dx in a theta.
Rookie mistake.
You're funny. All right. He always makes me laugh. All right, so here's my x, and this will be the last one, so hang in there. This one gets fine later. It's right now that this one had an issue at the front end. So there's my x. I need dx. So those are my things in the integral. My x minus 3 cubed got you in terms of theta. My dx will be replaced with what? 2 cosine theta. You might even, d theta, thank you. You might even want to, again, draw your line. This is all, I have not started. Isn't that sad? I have really not started. It's very sad. but fun, and I love it. It's not depressing, it makes my heart happy. Alright, so again, before I continue, I would, and some of you are already doing it, I get a triangle on my paper, right? Let's go do that. My triangle will be sine generated. Sine is going to be what? But x minus 3/2, yes, thank you. And then, Bestie, I shall go make it opposite over hypotenuse.
Other way.
Opposite. I don't know what side's the opposite. Over hypotenuse. Right? See, do you think Creek's failed on us? Can you tell which Susan is the one auditing the course and not actually in it? Alright. He was out in September. We love him though. God help you, you sat through the whole thing. What?
When you complete the square, do you still put the regular, the first radicand on the third side of the triangle, or do you put like the
What first radical? What are you talking
What?
There's so many letters and numbers. Do you put this one or like the new one?
Oh, I see. We're not done with that. He's answering. Hold on.
Okay.
He's asking when we go finish the triangle and we have the square root of c squared minus this. He said, do we go back? No, that was a good question. He said, do I leave that in completed square form or go back to the original? And the answer to my question is they're equal, so who cares? Right? If you want to, Dylan, if you want to go FOIL this out, do the whole thing, subtract it from 4, you will get the original issue back. Or we completed the square round, which I know we didn't because we double checked. Alright? And that's why. Alright. Back over here. I also would like to say theta is arc sine, just in case I'm going to need that. Now, sadly, and it is kind of sad but kind of cool, way back to the original, I am now going to start it. I almost forgot what I did. I was trying to create, I saw the root, I knew I was going to go trig, I was seeing the quadratic, I complete the square. They can't really get a whole lot more difficult than this, I don't think. No, see? Alright, so we're doing 1, but are we good so far? No, this is where we'll stop.
This is about as big as it gets before you would just give up and put it into Wolfram Alpha. It would take you literally a day of plugging and chugging.
I put it in. It made me puke.
No, we're gonna finish this, you guys. We got this, Elk River High School.
This isn't that bad.
Alright, so where am I going? Where were we?
Square root.
Oh, so let's go back to our original. I lost what I was even doing. Here it is. I'm gonna go from here. This is where I wanted it, so I can do my trig sub. So I'm gonna integrate 4 minus. What is this gonna be?
2 sines.
Theta squared. So 4 sine squared theta.
Square root.
Thank you. Thank you. dx is going to be replaced with 2 cosine theta d theta. Sadly, the margin is not big enough to contain my work, said who? I'm going to have to erase my helping triangle. All right, let's go clean this one up. In here, I will have, you should know what that's going to give you right now, right? 2 cosine theta, blah, 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 right? So 4 will come on the outside with the 2 and the 2. Cosine squared theta d theta. Now, yesterday we talked about how to attack that when it's in the integrand, right? That's not nearly as bad as the last integrand. It's not U sub, but we talked about, what did you say? Color reducing. Yep, let's go do that. Maybe you forgot it because we haven't been using it a whole lot. Go ahead and look.
The 1/2.
There it is. 1/2, thank you. 1 plus, I love it. 2 theta. Usually I have way more sleeping than just Creeks. And he's up. Welcome to the world. Usually people bail on this one. And if you remember in Calc 1 last year, we did 3 of these, the easy 3, like we didn't delve into numbers 4, 5, 6, or 7. And I told you guys I said you are totally allowed to bail. And yes. It's not a Calc 1 topic, but we're going to do it anyway just because it's good trig stuff. We don't get enough trig in Calc 1. Alright, let's clean that up. That's a 2. We are almost done. 1 plus cosine 2 theta. This is why it's gonna go ugly. Not because it gets difficult from here, it's just the back sub's gonna make it a little ugly. So, we integrated one like that yesterday too. What's the antiderivative of 1? You guys quiet. Hang in there, you got it. We're almost there. Perfect timing for me. Alright, how about the antiderivative of cosine 2 theta?
Half sine theta.
Thank you. Half sine 2 theta. We don't even have to discuss it. We do it in our heads. Don't forget our good friend, boom. Now, here's the deal. Yesterday we talked about this also. There's one part of that, guys, like you still gotta work with it. The sine 2 theta. It's got the double angle identity. This is loaded with all the trig stuff of our past. So let's go back up there. Do you remember what sine 2 theta was? If not, I gave it 2 sine, yeah. 2 sine, 2 sine, did you fake sneeze it? 2 sine theta, cosine theta. Alright. Almost there. Oh, so close! What would I have to do with all the thetas?
Plug 'em in.
Arctanum and sine and cosine's gonna go up from the triangle. Can we clean it?